My name is Jessica, and today I will be discussing the effects of solar radiation on the circadian rhythm. So, solar radiation can be defined as the electromagnetic radiation emitted by the sun, and this varies from ultraviolet to infrared. 42% of that radiation falls under the category of visible light, and that's what we're going to focus on today. So, the visible light spectrum is the section of the electromagnetic radiation spectrum that is visible to the human eye. And it varies in wavelength from 740 to 380 nanometers. In the early hours of the day, there is a higher presence of blue light, which is around 500 to 520 nanometers. And in the later hours of the day, there's a higher presence of red light, which varies from 625 to 740 nanometers. The Planck-Einstein relationship tells us that the relationship between energy and wavelength are inversely proportional. So if we look back, the radiation in the early morning is going to have higher energy due to the shorter wavelengths. The opposite is also true for the evening radiation, which will have lower energy due to the longer wavelengths. So the circadian rhythm is our internal clock that tells us when to wake up and when to go to sleep. And it does this through photoreceptors in the retina that captures photon energy and converts it to electrical signals through a process called phototransduction. When these photoreceptors are exposed to the high energy blue light that's available in the early hours of the day, this triggers the release of cortisol, which is most commonly known as the stress hormone, but it's also the hormone that's most associated with higher levels of alertness and wakefulness. This is what wakes us up in the morning. And then later in the day, when the photoreceptors are exposed to low energy red light, this triggers the release of melatonin, or the sleep hormone. And this is what helps us fall asleep at night. So, why do we care about all of this? Well, as it turns out, 90% of our time as humans are spent indoors, which means we're not getting the proper exposure that we need from the sun to regulate our circadian rhythm. And even if you have windows indoors, modern windows are made to filter out 99% of the sun's radiation. So you still won't be getting adequate radiation exposure. In addition, exposure to artificial lights throughout the day, especially later in the day, is also causing disruption to our circadian rhythms. This causes disruption in sleep patterns, which is also linked to increased incidences in mood disorders such as depression. So, how can we mitigate this? Well, the solution is pretty simple. Spending as little as 15 minutes outside during the sunrise and sunset has been shown to improve sleep patterns. In addition, it's important to minimize artificial light exposure throughout the day, especially later in the day. However, if you must use light, it's recommended to use low energy red lights, and even putting it at a low angle rather than overhead can help improve sleep quality. For shift workers, you can take advantage of artificial light to try to simulate the sunrise and sunset. For example, using blue light within 30 minutes of waking and red light a few hours before going to sleep can significantly improve sleep quality. And here are my references. Thank you so much for watching.